The moon has always been with us. It rises and falls in our skies, a silent witness to the entire history of humanity. But imagine this one day, when people look up at the moon, it may no longer feel like a distant, lifeless rock. Instead, they might see the future home of humankind. In recent years, interest in the moon has surged. More and more nations are turning their eyes toward establishing a permanent presence there. By late 2022, 6 major players, America, Russia, Europe, Japan, China and India, had already sent spacecraft to orbit or land on our nearest celestial neighbour. Soon after, a 7th joined them. But what is driving this modern-day race back to the moon? For some, it's the pursuit of knowledge and the advancement of science. For others, it's the lure of resources, economic potential, and the chance to stake a claim in a new frontier. Whatever the motivation there is, one truth: choosing where to build those first bases is critical, and that requires us to truly understand the moon's surface, its dangers, its mysteries, and its hidden opportunities. Fortunately, humanity has had a faithful scout circling the moon for over a decade. Since 2009, NASA's Lunar Reconnaissance Orbiter, or LRO, has been quietly mapping the moon in breathtaking detail, orbiting as close as 50 kilometres above its scarred surface. But what has it revealed? How might these discoveries shape the future of human settlement on the moon? And what new missions are helping us see even deeper into the shadows? Let's embark on this journey together. LRO was launched with a straightforward task map, the moon more precisely than ever before. And within just 1 year, that mission was accomplished. But NASA did not stop there. Instead, the orbiter was reassigned to a new purpose: investigate regions of special scientific interest. From the highest peaks to the deepest craters, from winding valleys called rilles to the scars of massive impacts, LRO became more than a cartographer. It became our detective, searching for clues that could change how we view the moon forever. Previous studies revealed fascinating features, but today let's go further, because some of LRO's most surprising discoveries point not just to the moon's past, but to the very places where future explorers might one day call home. One of the most important features for any future moon settlers might not be a mountain or a crater, but something far more humble: a hole in the ground. These are known as pit craters. At first glance, they look like dark, gaping mouths on the lunar surface. By studying the shadows, scientists determined that some of them are 100 metres deep and over 100 metres wide. Unlike typical impact craters formed by space debris slamming into the moon, pit craters are thought to be formed by underground cavities collapsing. In other words, they might be entrances to ancient lava tubes. If this is true, it means that beneath the moon's barren exterior could lie entire networks of caves carved by rivers of lava billions of years ago. The moon is cold and geologically inactive now, so these tubes lie empty and silent. But they offer something incredible. First, they could preserve a natural record of the moon's geological history, untouched for eons. But more importantly for us, they might provide ready-made shelters for human explorers. You see, the moon lacks a magnetic field and a protective atmosphere. Any astronaut on its surface is exposed to intense solar and cosmic radiation. Over months or years, this radiation would be lethal unless thick protective structures were built. But imagine setting up camp inside a lava tube. 100 metres of solid rock above your head provides the perfect shield, equivalent to building walls of concrete many metres thick. Nature has already done the hard work for us. It's not difficult to imagine the first lunar bases being established in such places where the moon itself becomes the roof and the walls of humanity's new outpost. Radiation protection is only part of the challenge. For a settlement to survive, one vital resource must be found: water. For decades, scientists believed the moon was bone dry. The only hope for water lay in tiny frozen pockets, hidden In permanently shadowed regions, the deep craters near the poles that never see sunlight, but LRO revealed something astonishing. Scattered across the surface, trace amounts of water molecules were detected clinging to lunar soil, the grey regolith that covers most of the moon. Even more surprising, this water seemed to move. By day, when the sun's heat scorched the surface, the water disappeared. But as the temperature fell with lunar night, it reappeared. A fragile, shifting lunar water cycle. Where did this water come from? Why doesn't it simply evaporate into space? These are questions that still puzzle scientists, but what matters is that the potential zones for human bases suddenly multiplied. Settlements would not have to be restricted to the freezing shadows of the poles. Instead, they might draw on water resources in many more regions across the lunar surface. It's a discovery that turned the moon from a desert into something far more promising, a world where water, however scarce, might be gathered and used. Still, the permanently shadowed regions remain areas of intense interest. With almost no axial tilt, the moon's poles harbour craters that never in billions of years have seen the light of the sun. It was logical to think these places could store ice. After all, without sunlight, there is no heat to melt it away. But just how cold are these eternal shadows? Thanks to LRO's diviner instrument, we now know the answer. Some polar craters reach an astonishing 250 degrees Celsius. That is colder than Pluto, colder than Neptune, colder than almost anywhere in the solar system. Such temperatures create what scientists call cold traps. Molecules of water, carbon dioxide, carbon monoxide, nitrogen and argon may be locked away here, preserved in a deep freeze. These compounds are essential not only for human survival, but also for future industries in space. But there is a problem. These craters are so dark that LRO's cameras cannot see into them. The very shadows that protect the ices also keep their secrets hidden. For that, we would need a new set of eyes. In December 2022, South Korea joined the moon-faring nations. Their first lunar orbiter, Danuri, also known as KPLO, entered orbit after a 4.5-month journey. This was more than just a national achievement. NASA and South Korea worked side by side on Danuri, sharing expertise, navigation and communications. And in return, South Korea made room for a very special instrument, ShadowCam. Think of ShadowCam as the younger sibling of LRO's cameras, but with one dramatic difference. It is 200 times more sensitive to light. With this extraordinary ability, it can peer into the darkness of permanently shadowed craters where no sunlight ever reaches. One of its first targets was Shackleton Crater at the lunar South Pole. This crater had been studied before, but always cloaked in mystery. ShadowCam revealed its interior in stunning clarity, a rugged floor covered with hummocks, even the trail of a boulder that had rolled down its wall and never been erased by wind or weather. What was missing, however, was equally important. Shackleton showed no obvious ice. Perhaps the crater is too small or not quite cold enough to preserve it. It was a moment of both wonder and humility. The moon does not give up its secrets easily. And yet, with ShadowCam, we now have a tool to keep looking across all the hidden terrain of the lunar poles. Over the coming years, Danuri may show us exactly which craters hold the resources that humanity needs. So where does all this leave us? Thanks to LRO and now Danuri, we are building the clearest picture of the moon in human history. We are uncovering a subtle water cycle. We are locating possible cold traps rich in frozen compounds. We are discovering natural shelters that could one day protect astronauts from deadly radiation. Piece by piece, we are laying the foundation for future civilizations beyond Earth. The moon is no longer just a distant light in our sky. It is becoming a world of opportunity, a world where bases might grow into towns and towns into cities, where the first steps of astronauts may one day give way to the first homes of families. One day, perhaps not too far From now, millions of people might look at the moon and not see a foreign body in space, but a second home, and when they stand there gazing back at Earth, they may whisper the same word we all long for home,